All right, so we're supposed to convert 2 radians. So to convert 2 radians, I'm going to think, okay, I'm going to multiply by a fraction. That fraction needs to have a degree symbol on the bottom so my degrees can actually cancel out. Well, to have degree on the bottom, we're going to go 180 degrees and pi, and maybe we could turn that into a 1. So that's going to give us 215 pi divided by 180, noting that the degrees would cancel out. That reduces down to 43 pi over 36. If you estimate this, the only thing you could do is put 43 over 36 in. Don't ever eliminate the pi unless I tell you to. The pi is only limited on degrees. You want that pi in there to let you know it's radians. So leave the pi. All right, next one is negative 22 degrees. We're going to follow the exact same script. We're going to multiply that by pi over 180. That's going to equal a negative 22 pi over 180. The degrees will cancel out. That reduces down to negative 11 pi over 90. I guess 2 just goes into that one. To convert to degrees, we're going to do the same thing. We're going to multiply by a fraction. This time, though, I want to put pi in the denominator. I want the pi's to cancel out. So that means my 180 degrees is going to go on top. That way my pi's cancel out. I'm left with 14 times 180 divided by 9. This is one that you can just plug in your calculator. This one comes out really nice. It's just 280 degrees. 7. How do I know that's a radian? How would I know if I just put on here convert to degrees or radians? Your choice. How do I know that this is a radian? Yeah. There's no degree symbol. Nope, there's no degree symbol. Either I messed up writing it, or it is a radian. If you're ever confused, just ask me, Mr. Pavin, did you mess up, or is that supposed to be radians? All right, like if you're on a test, ask away. All right, but we know it's radians because there's no degree symbol. This is probably the trickiest one because you can't actually see it cancel out, but you have to have pi on bottom, 180 on top. This would be something you plug in your calculator. You're going to type in 7 times 180, and then you're going to divide that by pi, and that should come out to about 401.1 degrees. Questions on any one of those 4, particularly if you got it wrong, and you're just like, I thought my way was good too. Good on those? All right, then let's go to the most important part of today's lesson, and that is actually asking questions on last night. Or Fridays, I should say. Friday's homework. What questions do we have on Friday's homework? And then I forgot to record a lesson, so here we go. Let's have a lesson on it. But this was the same as yours. Trig review. Remember SOHCAHTOA way back when in geometry? I know I taught it to my geometry students, but anyway, SOHCAHTOA. That is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And just a quick reminder, these only work if you have a right triangle. You have to have a right triangle. And you have to notify which angle you're talking about. So if we look at this angle right here, the opposite's going to be the one that's directly across from it, if you remember that. It's directly across from it. And your adjacent is going to be the one that you kind of have to do a curly Q if you want to draw it on. Adjacent is actually touching that angle. Your opposite side doesn't even touch that angle. So if I'm looking at theta, that is that symbol there, theta. If I'm looking at theta, the sine of that angle, or sine of theta, is going to be opposite over hypotenuse. For cosine, we're going to have adjacent over hypotenuse. And tangent is going to be opposite over adjacent, but we aren't going to be dealing with tangent today. We're just focusing on sine and cosine. Real quick, let's prep ourselves for something that's coming up. Let's say our hypotenuse is 1. Picture our hypotenuse as being 1. That means cosine would equal adjacent over 1, or it would just equal your adjacent side. Sine would equal opposite over 1, which would just be opposite if your hypotenuse is 1. That is the key to building that big bad boy up there. That is the key to your unit circle, is recognizing that your hypotenuse is going to be 1. But we'll get to that right now. All right, so we have a unit circle. I don't think I missed anything on here. All right, unit circle is a circle with a radius. We have a radius of 1. Centered at the origin. So when you look at that circle up there, that is just on your xy plane. So this circle right here is just a circle living on your xy plane with a radius of 1. So it's going to look something like this. Oh boy, that's a good circle. I should just retire right now. For those that haven't, that's a freehand circle too. That wasn't my circle tool. You can see it's kind of janky in places. All right, we use that unit circle to compare angles in degrees and radians and finding exact values of the 6 trig ratios. So the unit circle is going to allow us to know the values of sine and cosine at specific places, so we don't need our calculator to actually solve it. So what I'm going to do now is I'm going to draw a triangle in here. I'm just going to draw a triangle. And that triangle is going to end on a point of our circle. What is the hypotenuse of that triangle? I already gave it away. What's the hypotenuse of the triangle? If we have, it's going to be 1. This is a unit circle, has a radius of 1, so the distance from the center to anywhere is going to be 1. So any triangle I draw on this thing is going to have a hypotenuse of 1. And then what I want to point out also is this point, let's go up here. This point is the point x, comma y. Where we go right, x units, and we go up, y units. So I'm actually going to put that on my triangle. The base must be right x units. Might be 0.5, might be 0.6. And then we go up y units. And now what I'm going to do is I'm going to focus on this angle right here. Now I have a hypotenuse of 1, an opposite value that's y, and an adjacent value that is x. So now when we talk about sine and cosine, we're not going to have to worry about a whole bunch of numbers. We're just going to have to worry about this number and that number. Because in that little empty space there, we're going to say, let's say Mr. Papian asked me to find the sine of theta. He said, find the sine of theta, find the sine of this angle here. Well, remember, sine is opposite over hypotenuse. So it's opposite over hypotenuse. Well, I said that my opposite is going to be that y value. It's going to be the height that that triangle goes up. So my opposite is just going to be y. And we already said the hypotenuse of any triangle that's in here is 1. So that's y over 1, or just y. So if I knew this value right now, I would actually know the sine of that angle's value. I'd be able to go sine of this angle equals this y value. Who wants to take a guess at what cosine theta is going to equal? It's toughy. It's a toughie. Sorry? It's going to equal x. And if we follow that same train of logic, we have cosine of theta equals adjacent over hypotenuse. Our adjacent to theta is that value x. Our hypotenuse is still 1. So our cosine of that angle is going to equal x. So here's what I want you to start seeing. You see all those values that go around the unit circle? They look like x, y values. Those are actually your cosine and sine values. So when you're seeing a unit circle, what I want you to start seeing is, instead of seeing x, you need to think of your cosine value. If you see that y value, I want you to think of your sine value. So when I say sine, think of that second number. That's all the way around. Every second number up here is your sine value of the angle. Like if we look here, sine of 60 degrees is going to be square root of 3 over 2. If you plug that in your calculator, you can get that exact same value out. It just will be in a decimal. All right. Right below it is just the information I said. Sine theta equals y, cosine theta equals x, or xy. Think of cosine, comma, sine. You have to keep those in order. Don't flip them. Sine comes second, cosine comes first. All right, let's talk about some of those values in quadrant 1. What is the hypotenuse of every one of those triangles? What is the hypotenuse of every one of those triangles? Okay. It is 1. So this hypotenuse is 1, 1, 1. I'm going to tell you the specific measures of each of these angles. These are those key ones. We're going to put them in degrees right now, but we had to memorize 30 degrees. We had to memorize 45 degrees, and we also had to know 60 degrees. Those are our big ones. If we have a 30, a 60, or a 45 degree triangle, if you remember back in geometry, if you had a 30, 60, 90 triangle and you knew one of the sides, you could find the other two. It might be more realistic that you just memorize kind of these values. They're really easy to memorize. Let's start here, actually. What's the value of this point? Not the value. What is the x and y? So if I had to plot this, what is the x and y of this point right here? Remembering that this is just a circle on the xy plane. What is this point? Take a shot at it. Yeah.
1.
It's going to be 1, 0. So that should be one that you don't need to memorize. It is right 1, and it's up 0. So keeping that in mind, can someone else tell me what is the xy value of this point? What is the coordinates of this point here? Olivia?
0.
It'd be 0, 1. Those are the easy ones. All right, the other three are a little more difficult, but the nice thing is they're always going to be fractions, and they're all going to be fractions over 2. So I can go ahead and fill in a majority of this. Fraction over 2, fraction over 2. Here's how I fill the rest of this in. This is how I remember it. I use sine as my sine. So I'm going to do sine first. Sine is my sine. I'm going to go 0, 1, 2, 3. I'm going to go 0, 1, 2, 3. It counts up. So 0, 1, 2, 3. And then cosine goes the opposite direction. It starts 0, it goes 1, 2, 3. And then anything in the numerator has a square root symbol on it. So we have square root of 3, square root of 2, square root of 2, square root of 3. If you want to, you can put the square root of 1, but the square root of 1 is 1. And these are, we did this in geometry, a 30-degree triangle with a hypotenuse of 1, has a base of square root of 3 over 2, and a 1/2. That's exactly how it works out. So those are correct values. A good thing to recognize is square root of 2 over 2 always goes with square root of 2 over 2. So if you know one of them, you know both of them. Square root of 3 always goes with the 1. Square root of 3 always goes with the 1. So if you know the sine value of each of these, you know the cosine values as well. All right, questions on those? Those need to be memorized. They need to be memorized. But like I said, in my mind, everything's over 2. That's easy enough. And then I use sine as my sine. Sine goes 0, 1, 2, 3. Then I know what my cosine value is as well. Okay, how do I read this unit circle? So remember what I said. I said when you see those x, y values, what I actually want you to think about is the fact that it's cosine, comma, sine. For every one of these is cosine, comma, sine. They're actually giving the cosine and sine values. So if we look at this little chart, if they ask you what is the sine of 0 degrees, which is also the sine of 0 radians. You look at your unit circle and you go, okay, 0 degrees is right here. 0 radians is this bar that goes right here and it's pointing to this point right here. Well, this point tells me that cosine equals 1 and sine equals 0. So we could fill in both of these. Okay, my sine I said was 0. So the sine of 0 is 0. Yeah. What would the cosine of 0 be then? Yeah. It's going to be 1. I guarantee if you plug in your calculator right now, if you take out your calculator and you type in sine of 0 degrees, in fact, if you have a calculator, type it in so you believe it. Type in sine of 0, type in cosine of 0. Do you get 1 and 0 out? Yep, and that will work for every one of these. So these are, so you don't need your calculator. In geometry, you always use calculators for sine and cosine. In pre-calculus, we're going to use sine and cosine so much, we don't want to have to use our calculator every single time. We just have to have these numbers memorized. Plus, your calculator is going to approximate these values. I need the exact values. When we have to get square root of 3 over 2, your calculator is just going to approximate it. I need exact values for this whole section. All right. Our next one is sine of 30 degrees. What is 30 degrees in radians? What is 30 degrees in radians? Come up with, well, we already did the first one. The second one is going to be square root of 3 over 2. Our next one's going to be square root of 2 over 2. Then we're going to have 1/2. And then we're going to have 0. Notice the pairs. Did I mess one up? Yeah.
Well, I'm just wondering, why is the sine of 45 degrees square root of 2 over 2?
It's going to be square root of 2 over 2. Yep. They're always going to have square roots. The only ones that don't have square roots, so think of this as being square root of 1 over 2, but a square root of 1 equals 1. So you can put a square root on it. Just make sure all your numerators have square roots on them. Other questions on any of those, because what we just did is huge. We're going to be doing that a ton in this. So if you don't know what I'm doing, you're going to be lost for a while. Okay. Another thing we need to remember when we're dealing with the unit circle is this little saying here. All students take calculus. All students take calculus. What this says to you is in quadrant 1, all trig values are positive. Students, sine is positive, everything else is negative. Take, tangent's positive, everything else is negative. And finally, calculus, cosine is positive, everything else is negative. We're going to particularly need that tomorrow. So remember, all students take calculus. That way you know if it's positive or negative depending on the quadrant. Yep.
So there's never going to be a situation where like 2 or 3 of them are positive?
Correct. It's either going to be all of them are positive or just one of them is. Let me preface that with, remember sine goes with cosecant? If you remember that from, they have, you just flip it. So cosecant is the flipped. So sine goes hand in hand with cosecant, cosine goes with secant, tangent goes with cotangent. So If one's positive, the other one's positive. But the core ones, it'll either be all of them are positive or just one of them's positive. Didn't mean to throw that wrench in there. I just didn't want to give an absolute that isn't an absolute. All right, find the exact value of these. All right, so now we have to fill out kind of our full unit circle. So we're going to go ahead right now and fill out our full unit circle with degrees, radians, and all of our x, y values. So let's start with degrees. Degrees should be the fast one. Degrees go 0 degrees, 30, 45, 60, 90, 120, 135. Remember, for degrees, you're just thinking 30 degrees and 15 degrees between anything. 150, that should get me back to 180. This gives me 210, 225, 240. Then we have 270, 300, 315. Finally, we're going to have 330. And you could, if you wanted to, put that 360 degrees. Radians, I'm going to fill in my key ones first, the one on the left, right, up, and down. I'm going to do those first. 0 degrees is the same thing as 0 radians. 90 degrees, I guess I can use this as a fraction, is going to be pi over 2. 180 is going to be the same thing as pi. And way down here is, I don't really have room to do that, but it'd be 3 pi over 2. What are the 3 denominators I need to remember for radians? There's only 3 denominators I need to remember because that's all it's going to be in those. What are those 3 denominators? Yeah. 3, 4, and 6. Yep, 3, 4, and 6. We're going to have 3, 4, and 6. And remember, I start at the 2, and I just kind of trickle down in both directions. So it's going to go 2, 3, 4, 6. 2, 3, 4, 6. And then go the opposite direction, 2, 3, 4, 6. It's a mirror image on the bottom. And just a reminder, they all have pi in them. They just might need a number in front of it, so I'm going to go ahead and put pi on all of them, and then we'll take care of what goes in front of the pi. I'm in quadrant 1. What goes in front of that? Technically a 1, but we're not going to put anything next to it. Yeah. All right, so she took the easy one. 2. If I'm in quadrant 2, what goes in front of it? Olivia? And subtract 1. So 3 becomes 2, 4 becomes 3, 6 becomes 5. I'm in quadrant 3 now. What goes in front of the pi's in quadrant 3? Yeah, someone knew. Easy.
7, 5, 4.
How'd you come up with that?
Quadrant 3 is 1 more.
It's 1 more. Yep. So 7, 5, 4. And then what happens when I'm in quadrant 4? Tori?
Multiply the denominator by 2 and then subtract 1.
Yep. So 6 becomes 12. Subtract 1, it becomes 11. For those that actually studied it, was it that bad? No. And now we're going to add one more thing to it, which shouldn't be that bad either. Let's do the core 4 points. You have to remember, these do not need to be memorized. These 4, remember, this is on an XY plane. This is the plane that goes 0, 1, 2, 3, 4. So this is just a point out here. It's a point that goes right 1, up 0. This is the point 1, 0. Which means at 90 degrees, I'm not going left or right, so that's 0, up 1. That's the point 0, 1. Left is going to be negative 1, 0. And finally, if I want to go straight down on an XY plane, I'm going to go 0, down 1, so that's 0, negative 1. Now let's handle the first quadrant like we did up above. Remember, we're going to have points. And those points are all going to be fractions with 2 in the denominator. You just have to, one way or another, figure out that sine is your first one that has a 1 by it. I go with sine is 0 at 0 degrees, so it's 0, 1, 2, 3. So I'm going to do I always do my sine first. I go 1, 2, 3, and then I put square roots on everything. And that means cosine goes the opposite direction. It comes down 1, square root of 2, square root of 3. Let's move to quadrant 2. Quadrant 2. Oh, that was an lucky one. All right, for my quadrant 2, if sine went 1, 2, 3, it's going to also be a mirror image, kind of like our radians. So if I go 1, 2, 3, I'm going to go 3, 2, 1, 0. So sine, you can just count up and down. So once again, these are all over 2. And sine's going to count down. It's going to go 3, 2, 1, and it's back to 0. And then I put my square roots on it. So I always tackle the sine first because cosine's just going to be the opposite pair. So square root of 3 over 2 goes with 1/2. Square root of 2 goes with square root of 2. 1 goes with square root of 3. Here is the only thing we need to remember. All students take calculus. What is positive in quadrant 2? What is positive in quadrant 2 according to that all students take calculus? Yeah. Sine is positive, which means cosine is negative. So we need to put negative signs on all of our cosine values. And then we'll come down here. I'm still going to do sine first. But they're all over 2. Sine still follows with, I'm going to count based upon the 0. It's going to go 0, 1, 2, 3. Once again, you can think of mirror image as well. It's mirror image, 1, 2, 3. And that means cosine would have started with square root of 3, square root of 2, and 1. Now we have to go back to all students. Sine is positive. Take, tangent is positive. Everything else is negative. So we do have to put negative signs on all of these. I'll put it in red because I'm kind of small here. So it stands out a little bit more. But those are all negative. All right, let's finish up the quadrant. Quadrant 4. Bless you. You're welcome. All right. Once again, sine went 0, 1, 2, 3. Sine is going to go 3, 2, 1, back to 0. So in my mind, you can memorize it however you want to. I just use sine. I always say sine is my sine. It goes 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3, 3, 2, 1, 0. That way I have it done. In fact, if I had to fill this out, I'd probably fill out all my sines, and then I'd fill out all my cosines. So it's going to go 3, 2, 1, which means cosine went 1, square root of 2, square root of 3. In quadrant 4, one of them is positive, one of them is negative. Which one is negative in quadrant 4? I'm in quadrant 4. I have either sine or I have cosine. One of those is negative. Which one is it, Olivia? Sine is going to be positive or negative. Yep. Because it's all students take calculus. Cosine is positive, which means my sine is negative. Throw some big old negatives on there. Otherwise, you lose points. That's your unit circle. This is the bulk of it. You have to have all of this memorized so you can put it down. There will be, I won't call it a pop quiz. You're going to know it's coming-ish. Just every day we don't have a quiz on this, you're more and more likely to have one. Usually, yeah. Know it tonight, practice it. Online, there's plenty of blank unit circles you can print out and practice them, or you can just draw a circle and just practice them on your own. Get your degrees, radians down, so you have a little more time to think about these. But know that entire thing. Because now we could have questions like, what is the sine of 135 degrees? Who can tell me what the sine of 135 degrees is? What is the sine of 135 degrees? Hannah?
Square root of 2 over 2.
Square root of 3 over 2?
2 over 2.
Square root of 2 over 2. Yeah, that makes more sense. Positive or negative?
Positive.
Positive. Yep. We are in quadrant 2. All students, so it's going to be positive. So let's double check this. So we have 135 degrees. 135 degrees. Awesome. They're both square root of 2. So it's going to be a positive square root of 2 over 2. All right. What's the sine of 5 pi over 4? First of all, what quadrant is 5 pi over 4 in? How do you know it? Yes.
Or the third quadrant.
Third quadrant because it's... I'm comparing the numerator to the denominator.
Oh yeah, because you had one.
Because you add 1. Yep. So I'm in quadrant 3, which means it's negative to begin with. And then what is that value? What is the value of 5 pi over 4? Looking at that unit circle. Tori? Negative square root of 2 over 2. Square root of 2 over 2. Let's see. So I said 5 pi over 4. 5 pi over 4. We just have to locate it here. It's negative square root of 2 over 2. All right. I'm going to skip that. No, I'm not going to skip that. We have negative 7 pi over 6. Is negative 7 pi over 6 on our unit circle? No, it's not. We have a positive one. How can I make a negative angle positive? So I can put it on that unit circle. We practiced it on when we did degrees. We practiced it when we did it on radians. It has to do with coterminal angles. How do I make this positive? How do I have an angle in the exact same place, but it's positive? Maybe? No? Yeah.
You add 2 pi.
We're going to add 2 pi to it. Remember, 2 pi is, I'm in the same place, I'm just spinning, I'm there. So I want this to be in the exact same spot, but I want it positive. I want it between 0 and 2 pi. So we're going to add 2 pi to it. So we have negative 7 pi over 6. Add 2 pi to it. Well, we have to have a common denominator, so that'll be 7 pi over 6. Plus, well, that'd be 12 pi over 6. Which is going to equal 5 pi over 6. So sine of negative 7 pi over 6 is the exact same thing as sine of 5 pi over 6. They're exactly the same thing. I'm in quadrant 2 because it's one less, so I know sine needs to be positive. In quadrant 2, sine needs to be positive. So I know my answer is positive. And what is 5 pi over 6? Yeah,
1/2.
1/2. So it's a positive 1/2.
We also only add like 8 pi, and we did the pi over 6 would be the same thing.
It would be, but don't do that yet.
Okay.
We're going to talk about it tomorrow. It's called using reference angles. I can actually just cover up that negative 7 and go pi over 6. Find pi over 6 on your unit circle,
Yeah, it's 1/2.
and it's 1/2. So we're going to learn tomorrow why you can just cover up this number for these. As long as you know what quadrant you're in. As long as you know what quadrant you're in, you can cover up this number, and you can actually put everything in the first quadrant. All right, next one says cosine squared of 30 degrees plus... The only reason why I'm doing this one is I want to show you a different way to write this. So when I see cosine squared of 30 degrees, what you're actually doing is cosine of 30 degrees, and then you're squaring it. Plus sine of 30 degrees, and then you are squaring it. So the square is actually on the outside. We just put it here so it doesn't get lost. It doesn't look like I'm doing 30 squared and then taking cosine of it. That's why we put it right here, but you can write it like that as well. Well, the cosine of 30 degrees is actually going to be square root of 3 over 2. Plus sine of 30 degrees is 1/2. Square root of 3 over 2 squared is square root of 3 squared is 3. 2 squared is 4, plus 1 over 4 is going to equal 4 over 4, which equals 1. Do you think that's a coincidence that it equals 1? It is not. In fact, if you take this, if you go cosine of 45 squared plus sine of 45 squared, you're going to get a 1. If you plug in cosine of 60 squared plus sine of 60 squared, it's going to equal 1. That's going to be the base of a lesson coming up. It is called the fundamental identity of trigonometry. That sine squared plus cosine squared equals 1. All right, any questions on anything we covered today? You should have a yellow unit circle that's already filled in for you. In case you can't read your own writing, you're going to have a beautiful yellow. It's in yellow, it's not paged, so you can actually keep that loose. My advice is maybe don't even, if you're going to lose it, keep it where it is. Otherwise, stick it in the front of your binder so you can constantly pull it out and refer to it. We're going to eventually try to memorize all these values, but for right now, we're going to have to reference that sheet. Your homework isn't that long. It is just